So, hello and welcome to a new video. In the previous video, we introduced this integral here, which contains exponentials, and we basically transformed this integral containing exponential functions into an integral that only contains polynomial functions, which is much easier to solve. So we introduced this particular substitution here, and with this we were actually ready to rewrite the integral in this form. So now this is still an integral that is pretty difficult to solve. So in this video we are going to introduce what is called the partial fraction decomposition or partial fraction expansion. And this will help us in the end to rewrite this integral here into another integral that is much easier to solve. So what we are going to do is actually to take this expression here and use the method of partial fraction expansion and try to determine the constants a and b. So we have the expression here from the integral, and we say that this is equal to this sum of two fractions here. And what we are going to do in the first place is to multiply both sides of the equation here with the denominator, which is nothing else than t minus 1 times t plus 4. So what we will obtain, we have an equivalence still, is 2t, the numerator, equals, so what will vanish here is t minus 1 with this factor here. So what will remain is a times t plus 4, plus second constant that we are looking for times t minus 1. And with this we are ready to expand on the right hand side. So still on the left hand side we have 2t equals at plus 4a plus et minus b. So what we see actually is that we have two types of expressions. We have terms that have the variable t, that contain variable t, so at and bt. And we have two expressions here, two terms that are independent of the variable t. So we are going to regroup the two types of terms, and what we will obtain is actually 2t equals a plus b times t plus 4a, the remaining terms, minus b. So here on the left hand side we have an expression containing the variable t. So this expression here, or this equation here, splits into two equations. So we have still the equivalence here. So what we have is 2t equals, we have 2 equals a plus b. So this term here times t, so t will disappear. And we have a second expression, which is 0, because this is like basically plus a term that does not contain t, so it's plus 0, equals 4a minus b. Okay. So from this expression here, we can actually say that a equals 2 minus b. And then we are going to substitute this expression here into this equation here. So basically we say that we have like 1 prime, and we put here 1 prime in it. So basically we have 0 equals the expression, so 4 times 2 and 4 times minus b minus b. So in the end what we have is we have minus 8, so we take the 4 times 2 on the left hand side equals minus 5b. And from this we can actually solve for b, saying that b equals 8/5. So we found the expression for b, and now we can go back to the equation 1 prime and look and determine for a. So what we will call this expression here, let's call it 2 prime, and then With this, we basically have an equivalence here saying that we are looking for a equals 2 minus, then we insert the expression here. So minus b, and b is like nothing else than 8/5, so we have like 8/5. And so this is equivalent still, and a in the end is nothing else than, so 2 is actually nothing else than 10/5 minus 8/5, which is in the end 2/5. So what we actually managed to do is to rewrite running out of space, so we will write this here in the corner, the final solution. So what we find is that the expression that we were interested in the beginning, so 2 times t minus 1 times t plus 4 is nothing else using the method of partial fraction expansion. So we found the expression for a, which was here 2/5, so 2/5 over t minus 1 plus the expression for b, which was 8/5 over t plus 4. So what we actually managed to do is to rewrite the integral here into a sum of 2 integrals. And that's actually what we were going to solve in the next video, where we are really going to solve the integral, and then we have solved the initial problem, and we can actually write down the solution of the integral. So if you have additional questions or comments, please leave your question or comment in the comment section below. Like my video, subscribe to my channel, and see you next time.